Good morning, students. Welcome to the Chemical Process Synthesis, Unit number 1, Part A, Lecture 2. In previous lecture, we have learned about introduction to chemical industries, types of chemical industries, fundamental areas for chemical engineers, and basic need for chemical industries. Now, in this lecture, we are going to discuss about the introduction to unit processes and unit operations. Any chemical production facility or any chemical industry is a combination of some chemical changes and physical changes. And a chemical engineer applies the fundamental knowledge of unit processes and unit operation for commercialization of chemical process and product. So here, what is meant by unit process and unit operation? Okay, we'll discuss about that. So unit processes, what is it? Unit processes are the chemical reactions occurring in the many type of chemical industries are named as unit processes. Okay, the chemical reactions which are named as like oxidation, reduction, nitration, sulfonation, these are called as unit processes in the chemical industries. Now we'll discuss these unit processes one by one. So the first unit process is alkylation, and alkylation is addition of alkyl radical with any substrate. We are going to discuss about one example like alkylation of olefins. Olefins are unsaturated hydrocarbons. Okay, so the example, isobutane reacts with one butylene to produce 2 to 4 trimethyl pentane. Okay, so the substrate is butylene, which is olefin. Okay, for reactions are typically used in petroleum and organic chemical industries. Okay, so we can understand what is the mechanism behind the reaction. So the mechanism of this reaction is explained here. So the butylene, which is a substrate, in this the double bond will be broken, right, and these electrons will be transferred to the terminal carbon atom. So that negative charge will attract the H plus ions from the catalyst, and CH3 will be formed here, right? And because of shifting of electron, this second carbon will get positive charge. Therefore, this carbocation will be formed. And in next step, this carbocation, okay, so this carbocation will with isobutane to form one of the intermediate, and that intermediate is not stable, that's why it will be undergoing in the rearrangement reaction to form a final stable product. So this is overall mechanism of this reaction. We have already discussed or we have already learned the mechanisms of various reactions in 12th class. So in this unit or in this subject, our objective is not to understand the mechanism of reaction. Okay, so our objective is just to understand what is the name of unit process and what is happening in this unit process, and what are the applications of these unit processes in various industries. Okay, this is only our objective. So we'll discuss the definition of this unit operation or unit process, right? We'll only focus on the definition of unit process and its equation, that is overall equation, and its application in typical industry. So the next unit process is amination, right? So amination can be carried out by two mechanisms or two types, right? So first, amination by ammonolysis. Here the ammonolysis, okay, so lysis words means lysis means breaking the bonds. Okay, so here ammonia is being used as one of the reagent to break the bond and form new amine products. Okay, that is a basically meaning of amination. For example, we'll discuss the example of ethylene dichloride. The ethylene dichloride will react with ammonia to form ethylene diamine and ammonium chloride. Okay, here ammonia is used to break these chloride bonds, and new bonds are formed, that is amine bonds are formed. Okay, so these types of reactions are being used in dyestuff, organic chemicals, and synthetic fiber industries. So that much of discussion or that much of introduction of this amination unit process is sufficient for this purpose. Okay.
The third unit process is amination by reduction. In this, organic compounds containing carbon nitrogen bonds like nitro compounds, these are getting converted into amines by reduction of this functional group like nitro functional group. Okay, one example, nitropropane, 2-nitropropane. On the second carbon, there is a nitro group which is having oxygen. It is getting reduced by addition of hydrogen to form amine group. So the final product is propane to amine. These types of processes are used in dyestuff and organic chemical industries. Another unit process is ammono-oxidation. It is also known as ammonia oxidation. In this substrate, that is carbon containing compound, is reacted with ammonia and oxygen or air to form nitrogen containing compounds such as amines, amides or nitriles. One example is here, the propylene, which is having terminal carbon that is in the form of CH3, right? So alkane group is there. It is reacted with ammonia and air to form acrylonitrile. In this, the propylene, which is CH3 group is at the terminal end. It is getting oxidized to form nitrile group, that is CN. So these types of reactions are used in plastic and synthetic fiber industries. The next unit process is calcination. So calcination is basically heating any material at high temperature in the absence or limited supply of oxygen or air. Okay, so the chemical compounds like organic or inorganic compounds can be calcined, okay, at high temperatures like 900 degree or even more than that, depending on the product required. So that reaction is or process is carried out in the absence of oxygen typically. But if the oxygen is in excess, then that will be oxidation process, okay, and it will be getting converted to carbon dioxide. Okay, so calcination is typically having absence or limited supply of oxygen. So one example is limestone, which is heated at high temperature to form lime and carbon dioxide. Okay, so these types of calcination processes are used in cement industries as well as to prepare catalyst in different chemical industries. Then combustion unit process, we know that combustion means conversion of any carbon containing compound to carbon dioxide and side product water is formed. So combustion is exothermic reaction, so therefore it is able to produce that is heat as well as light. So this type of reaction is generally used for process heating, like for the production of steam. The next unit process is combustion. We know combustion, that is hydrocarbons are completely reacted with oxygen to produce carbon dioxide and water is formed as side product. Basically in this combustion, the carbon is ultimately getting converted into carbon dioxide. Okay, so in this reaction we know that this is exothermic reaction, so therefore this reaction can be used for the production of heat, or it is also used for lightning purposes. So process heating is typical use of this process combustion unit process for different chemical industries. So for example, methane can be combusted in the presence of oxygen or air to produce carbon dioxide and water molecule, and heat is produced in this process. So the burning or combustion of methane, or we can say natural gas or methane, that is biogas. Okay, so these types of fuels can be combusted to have the process heating utility. So the next unit process, that is carbonylation. Carbonylation is basically addition or introduction of carbon monoxide molecule into the chemical compound or organic compound, and this often results in the formation of carbonyl group. Okay, this carbonyl group can have the different products like aldehydes, ketones, esters and carboxylic acids, or even their derivatives. So one of the example of this process is methanol reacted with carbon monoxide to form acetic acid. So this carbon dioxide is getting added into the methanol to form carbonyl group, that is acetic acid group. Okay, so carboxylic acid is formed as a product here. So other products can be also produced using carbonylation like ketones, aldehydes or esters. And these types of reactions or unit processes are used in organic chemicals. Next process is carboxylation. Carboxylation is typically the addition of carboxylic acid group into the organic molecule, and in this the reagent or reactant is carbon dioxide. So for example, sodium phenate is reacted with carbon dioxide under high pressure or even in the presence of a catalyst to produce sodium benzoate. Okay, so that carboxylic group, okay, that dash COO group is introduced in this compound, that is sodium benzoate is formed. So again, these type of processes are used in organic chemical synthesis industries. Another unit process is condensation. The condensation is basically addition or combination of two or more molecules to form a larger molecule. And typically in this reaction, elimination of smaller molecule is taking place, like water or HCl or any other smaller molecule. The example of this condensation processes are, like first example is synthesis of cinnamaldehyde. Okay, so the benzaldehyde and acetaldehyde reacts, and sodium hydroxide is a catalyst for this process. So benzaldehyde reacts with acetaldehyde to form cinnamaldehyde. Okay, so basically these two molecules are getting combined to form a product, and water molecule is removed from this process. So this cinnamaldehyde is basically a fragrance creating compound, so that is used in perfumes. So this is one of the application used in the synthetic perfume industries. Another example is anthraquinone production. So the example, phthalic anhydride is reacted with benzene to produce anthraquinone. Okay, so anthraquinone is one of the dye intermediate. So this type of processes are used in dye stuff or chemical industries like organic chemical synthesis industries. Another unit process, that is cracking or pyrolysis. It is basically the breaking down of large hydrocarbon molecules into the smaller molecules at high temperature. The targeted molecules are valuable compounds. So cracking is involved in petroleum, in refinery industry. Thermal cracking of coal is also called as destructive distillation of the coal. So in the process where coal is converted into the liquid fuels, the thermal cracking is carried out, and this is called as destructive distillation process. So basically these processes are taking place at high temperature in the absence of oxygen. So one of the example of cracking is heptane. Heptane can be cracked under high temperature in the presence of catalyst to form two different products like propane and butene. Okay, so this 7 carbon compound is converted into two compounds like 3 carbon compound and 4 carbon compound. So this is just example, but this process is carried out in the petroleum industries for different purposes, or to convert even larger molecules like containing carbons like more than 20 number of carbons in the chain. These are getting cracked to form smaller molecules like if of the grade of diesel or petrol grade compounds. So next unit process is cyanidation or cyanation. Is addition of cyano group in the organic molecule. Cyano group is, that is C triple bond N, that is cyano group. So that cyano group is getting introduced in the organic molecule basically. So one example is acetylene reacts with hydrocyanic acid to form a acrylonitrile. So acrylonitrile is useful compound in organic synthesis. So this is used in organic chemical industries. Another unit process is cyclization. Okay, so linear hydrocarbons, okay, linear hydrocarbon chains like alkanes, alkynes, alkenes, these are getting converted into the cyclic hydrocarbons. That can be cycloalkanes or aromatics like benzene ring type of compounds can be there. So basically these type of cyclization reactions or processes are again used in petroleum industry, basically to convert the or basically to improve the quality of the fuel. Okay, by the cyclization the octane rating of the fuel can be improved. So one example is so hexane is getting converted to cyclohexane and terminal hydrogens are removed in this process,